So right now I'd like to welcome Ivan and Andrew Hogan, and they're going to talk to us about their new I/O interface. Thanks, guys.
All right, thank you. Hello, everyone. Thank you for giving us just a few minutes before we all dash for lunch. So I'm going to go through this a little bit more accelerated than I was originally intending, but that'll be all good. So, 2 years ago, we were here at Kfest, and we introduced a couple of different applications that dealt with what we did with our Apple. And so one of the things, the first application we showed off was the ability to control a roller coaster. And the ability to control a roller coaster. What could have just gone wrong in such a short time? So the Apple is interfaced to the roller coaster, it connects roller coaster, and snap circuits. And so we spent a bit of time talking about how we wrote the program, all the different inputs and outputs, and how it all works. The second application that we talked about 2 years ago was a rocket launcher. So we took the rocket launcher outside, ran the cables through the window, had the Apple control the rocket launcher. Third application that we talked about was an accelerometer. So we dropped objects through a tube, and then those objects would pass through some light sensors. Based on the timing of it, we were able to determine the acceleration downward, which is basically the gravitational constant. So those were the things that we did. And then we talked a little bit about the interfacing that makes it happen. And so I'm going to pass this around because this was the original interface board that we built back in 2010. And a little history behind that was my protege here was a little bit more like this back then. I know that. And so at the time I was the chief technology officer and the laundry guy and the guy who cooked and the guy who did all these other things. So I couldn't be looking over his shoulder all the time to see if he would take the snap circuits and maybe wire it backwards or short circuit something. And I was a little bit leery that an oops on the snap circuit side might release the magic smoke inside the Apple IIe. So the way that I did the isolation with that board was all with relays. All right, so I know relays aren't that sexy. They are extremely old school, but they work. And you can wire things, you know, polarity this way, polarity that way. You can do a closed contact, open contact. And so it's perfect because a kid who just wants to have a very tactile experience interfacing his Apple with his snap circuits can wire away and not worry about blowing anything up. So that's how that came together. And then when people saw this, they thought it was pretty cool. So they said, hey, can we get some of those boards just to goof around with? And we said, oh yeah, no problem, we'll have them next year. We didn't show up last year. So we had some problems trying to make these. And principally, one of the things that we ran into was trying to mill plexiglass. So I'm going to pass around all of our failed plexiglass so you can see what it looks like. And so what we did was we went to some tool and die shops. And those tool and die shops gave us some estimates about how much it would cost to mill something that to my mind was pretty simple. And they came up with estimates that exceeded the cost of the printed circuit boards. So we're like, no, we're not going to do that. We're going to try to do it ourselves. So like a lot of people who do maker care and that kind of stuff, we got a CNC mill. We got a CNC mill. And it was a Shapeoko. All right. So it was a really cool CNC mill, low cost. It used a Dremel, and it worked great on wood, but we just could not get it to work on Plexi. We just had nothing but trouble. So this year, we said, okay, we're going to Kfest, right? Right. How are we going to do that? We got to mill these things. Let's get a different CNC mill. So we got an X-carve. Anybody familiar with an X-carve? Okay, it actually uses a router, and it's much more stable, and that thing will blast through wood, and it does a pretty good job of being very steady and going through, just stop that. It does a very good job of being steady when going through plexiglass, but we still had a bit of trouble trying to get it to work. And during the Q&A, I will let Ivan talk all about the different trials and tribulations that he had, because this is the master of the CNC right here. He figured out how to do it. He did the CAD work, he babysat the CNC mill, he got it all working. But I like to use this analogy. Like a diamond, no two plexiglass pairs are quite the same. Because if you buy cubic zirconias, they're exactly identical. But diamonds all have a little imperfection. And so our little plexiglass tops and bottoms have a little imperfection here and there. And they're not, but we've come great strides. And a big testament to Ivan for all of his hard work for figuring out how to do that. Okay, so 2006, we're here. That's the interface board that we're passing around. And we did manage to make a run of 10 of these boards. And it will become apparent why we only did 10 when I start to talk about the cost of actually the parts that go into one of these guys. Because we talked a little bit about cost yesterday with the A2 Cloud project, and one of the numbers that sticks in my mind was when Ivan talked about how you can get a full-blown computer, a Pi Zero, for $5, right? A full-blown computer for $5. Well, we would love to sell these things for $5. But we would be losing our shirts because this is old school, retro tech, a lot of parts and pieces. Remember I said that there's relays on there and that's what does our magic for us. And so each one of those little micro relays is $370 a pop. There's 8 of them. The little push button switches for a run of, again, 10, we used 4 per board. Those were $390. Paddle switches, those were $2. And then there's one particular item on there which is grossly overpriced, and that is the dot matrix display, which does hexadecimal output. So it does 0 through F, and the hexadecimal display, it's not on that particular board, but it was on the original one that we made. That cost $28. And so, you start adding these numbers up. Oh, and to do a run of just 10 printed circuit boards cost $300 per circuit board for what we could get. And so you divide that by 10 boards, that's $30, but we have 2, so now that's $60. So it doesn't cost $5, as much as I would love to sell these for $5. I'm just talking about our cost of parts. So we only ran 10 because it cost us over $2,000 in parts just to make those 10. So we're going to try to recover the cost of parts and not the cost of labor, and just sell them at cost. Okay. So when you see the sticker, you will get sticker shock, but we're not trying to screw anybody. This is how much it really costs to do 10. Now, if we get a ton of interest and we can do like 50 at a pop, obviously you kind of scale. That'll bring down the price somewhat, but it's still not going to be a $5 deal. It's just not. We can't get it that well. Okay, so a lot of parts, very retro, very tactile, interfaces through the relays. What else can I talk about? All right, so I handed that out. Okay, next thing, try to keep it short because we're all hungry. There are 4 variations of the board that we made. After doing a little bit of research, we found out that our version is perfect for the Apple II, Apple II Plus, Apple IIe, because those devices on the game port, they have 3 paddle inputs, 3 button inputs. Turns out the GS has 4. So where did the GS get a 4th pin? Well, the GS doesn't have the cassette input, I believe, right? And so they used that input and they wired it into the paddle socket, and so that's your 4th button. And so we have a 3-button version that works swell with the 2 plus 2E, and we have a 4-button version, which we tested just this week because we didn't have a GS until we went to the garage fair. Yay! So we got one, we tested it, it works, and we're very happy about that. And so those were at least 2 flavors, right? So how do you get 2 more? Because I said there's 4. Well, there's the expensive version, which uses the dot matrix display for $28. And then there's the cheaper version, which uses a traditional old 7-segment display to do the hexadecimal output. And you might say, well, Andrew, why didn't you use that in the first place? Well, because I had a tough time finding a driver that did hex. They'll all do 0 through 9, but very few of them, and a decreasing number of them, and an increasing price. So I couldn't figure all that out for the very first prototype that we did. But I got it figured out now, and it uses a PIC processor to drive that. And so the advantage of the PIC is you can program it to do what you want it to do. And so when you plug in your boards, if you buy the 7-segment that you get, the first thing that it will do is it will spell out APPLEIOBOARD, Apple 2, I'm sorry, there's a 2, thank you. And so that's kind of cool, we got that to work. So, and then after that it shows you the hexadecimal output. So, I've passed out those things so you can see them, the original, and then the one that we've just milled. Talked about why the things, the white elephant in the room, why the heck do they cost that much, the parts. So any questions? I'll just open it up.
How much do they cost?
Okay, how much do they cost? 3 flavors. We have your Apple II 3-button option with 7-segment display, $195.
That's the cheapest one that we just passed out.
Yeah, it's the cheapo. And then the highest priced one is $230, and that's the GS because it's got the 4 buttons, so it's got an extra button and a relay, and it's got the 7-segment, or not 7-segment, it's got the dot matrix. And so the other 2 are about 220 and 205. Yes.
Since you've done this run of 10,
Yes.
have you had any head-smacking moments and found anything that's that you could have done considerably cheaper, or why didn't we do that, or maybe if the next run happens, then we can still charge the same amount and have slight profit?
Head-smacking moments, well, in a way, the first head-smacking moment, yes, I'll grant you that, was when I found out that there was no way that I could decrease the price by ordering the 2 different printed circuit boards at the same time together. They just wouldn't cut me a break. They're like, no, they're 2 different boards, so we're going to charge you double.
Charge
So-
set up twice, basically.
Set up twice, that's the problem. So if we reconfigure that so it uses 1 continuous printed circuit board, that would definitely drop the price. That was one of those head-smacking moments. Another head-smacking moment, which was a $600 head-smacking moment for me, which is more smacking it into the wall. I screwed up the first run. So what happened was I got the pins backward on the interface. And so, you know how when you look at an IC chip, it goes 1, 2, 3, 4, 5, 6, 7, and then that's 7, 4. And I thought, well, that's going to be the same for the DB connector, well, not DB connector, IDC connector, this connector, this guy right here.
Yeah.
And it wasn't. And so I thought, okay, we'll follow the same pattern around, and then swap them around. So I didn't do my homework. I just
The plug
assumed.
instead of the socket. You wired for the plug instead of the socket, or vice versa?
Yeah, so I had everything backwards. So I made 1 special cable so I could use the original, but after that, I'm like, well, nobody's going to want those Franken cables, so I just said, okay, I'm going to make it a run. Another problem that was a head-smacking moment, I'll admit to one more, and then I don't want to admit to anymore, was the fact that the paddles, the original game paddle goes from 0 to 150 kilo ohms, right? 0 to 150K. And I couldn't find any sliders that would go from 0 to 150. So I got some that went from 0 to 250, and I thought, well, we'll just put a resistor in parallel, and that'll work great. It works, but it's not linear anymore. And so then the head-smacking moment was, well, okay, so I won't wire it this way. If I go from 0 to ground and I put another resistor in parallel, then that will be linear. Yeah, except it's not 0 to ground, it's 0 to the capacitor, and then it floats. And so when I wired it that way, then as I moved the slider one way, the number went down, and then it went back up again. Yeah. So, then I'm like, oh my God, I can't believe it. So those were the major mismatches. But I can't really think of too many other ways of bringing down the cost. I mean, there's opto-isolators. If I take those out and use transistors to drive the relays, I'd probably save $8, but it would be a headache. So I think I'll just stick with those.
But one of the, just thinking, like you said, instead of doing the 2 separate circuit boards, doing it as 1 circuit board, and maybe they're notched or whatever, and you can break them apart. Things like that, where if you were doing it again,
Yep.
what would you do different? And you already said the circuit board, that was the one thing that I thought of was good. You have two separate boards for what reason instead of just having one long one, but yeah.
And it was
There's lots
just,
of that kind of stuff that you could probably optimize for if you were making 100 of them.
yeah. Initially, it was just geometry. I mean, I wanted to have the other board a little bit lower so it clears the panels, but yeah, I can still, Any other questions? Any questions about milling? You're the mill master.
What was the mill you ended up with?
X-carve.
X-carve, is that the one that you put down on the table and move it, or is it stable and you moves the head, or?
It's 3 axes that's controlled by the computer.
Yeah, if you go to Inventables, so.
Inventable, okay.
Yeah. And I don't have any relationship with those guys, but when I was looking at their products, the price for what it does, I'm like, okay, they made the Shapeco, it worked pretty good, but not for us, so let's try something different. And the X-Carve
Was really expensive.
yeah, it was a little bit more costly. Yeah, so now we're not just milling plexi, we've also brought here some other things that we've milled that we hope you love and you buy because there's much better margin for us.
You have a cool mill.
Yeah, exactly, we got a cool mill, we gotta use it. Okay, any other questions? So we hope to see everybody at the vendor fair, and you're free to go to lunch and enjoy, and thank you very much.